geologists skilled in the field of tunneling. And on the other hand, there are engineers who are looking for jobs. And as I said, this mismatch is because of the fact that we have failed to attract young talent into the universities, simply because in most of the universities in civil engineering, tunneling isn't taught in any great detail. This is, as I said, one of the bigger challenges. But let's talk briefly about some of the other challenges which are associated with tunneling. So for which I have to share my screen and take you to the presentation. Challenges of tunneling. Now, if I remove the word challenges from this topic, the meaning will still remain the same, because when somebody says tunneling, the fact that there are challenges is implied, because there are hardly any tunnel projects in the world which haven't had challenges. Tunneling is underground. Tunneling has so many things, some of which we are going to talk about in next few minutes, which bring a lot of challenges to this subject. And that is what makes this field of tunneling so exciting. So let's hear about some of the challenges. We've already discussed one of the challenges. Let's talk about a bit of philosophy to understand the next challenge. Tunnels are not like any other civil engineering structures. Other civil engineering structures, such as the building you're sitting in, such as bridges, the structures on the surface, they are built using material, for example, concrete, bricks, mortar, which have defined and testable properties. But that's not the case with tunneling. We'll talk about it in a bit, because there's a table coming up on the next slide, which is going to show you some of the issues associated with the tunnel construction with respect to the above ground construction. So let's compare these two types of structures, the traditional civil engineering above ground construction and tunnel construction, on the basis of three parameters: construction material, loads, and safety. Now, as far as construction materials are concerned, as I mentioned, buildings, bridges, and surface structures, they are built using materials which are man-made material, which have testable properties, and the properties can be guaranteed by quality control procedures. But that's not the case with tunnels, because tunnels are built largely using a material which is natural ground. The soil, the rock, the alluvium, the colluvium, the debris, the boulders, and we don't have the capacity to influence its behavior. So we are dealing with natural ground. Okay, now as a civil engineer, as a structural engineer, you can say that, okay, I need an M35 concrete, even M32.5 concrete, and you will be given. But you cannot order that I'll only build a tunnel in this rock when the compressive strength of the rock is 120 MPa. You can forget about building a tunnel. You have to build that tunnel in the given ground conditions. It is a major difference. Coming to the loads, now for the structural analysis of surface structures. You know the loads, the live load, the dead load, the wind load, the earthquake load, all kinds of loads, and you can design your structure for that. In tunneling, forget about it. You have to make assumptions. You're never sure about the loads, particularly for deeper tunnels. Now, I'll give you one of the examples. One of the deepest tunnels is 𝗏𝗏𝗣𝗏 tunnel in Switzerland, which was completed a few years back, 57-kilometer long railway tunnel. At its deepest, the tunnel is 2.3 kilometer deep below the top of the mountain. Imagine 2,300 meters deep. If you multiply that depth with the unit weight of rock, 2.6 to 2.7 tons per meter cube, you can imagine how much load will come on the tunnel. So clearly that much load is not coming. A part of that is coming. I don't have time to go into detail of that. One of the tunnels constructed the last year in India at its deepest is 1.9 kilometer. Clearly the entire load is not coming. So you're never sure about the load, right? Safety. We civil engineers eat factor of safety, drink factor of safety, sleep factor of safety. Everything is looked at in terms of factor of safety, a precise number, because we know the properties of the construction material. We know the loads exactly. It's possible to calculate a factor of safety. In tunneling, there are uncertainties associated with the loads, uncertainties with the material properties. Not just that, the inherent variability of material properties. You drill a borehole here and drill another borehole 20 meters away in the similar ground condition. it's unlikely that you'll get the exact same properties. There would be inherent variability. So not only that properties are not precisely known, you also have this inherent variability. Plus, there are issues with the knowing the loads. So it's not really possible to calculate a quantitative number called factor of safety. So it's all based on assumptions. Now, think about the uncertainties with the field of tunneling. In tunneling, you are dealing with the natural ground. But someone can say that I have been to tunnels and I've seen so much of man-made material used there. For example, this picture, which is from a tunnel being constructed under New York, has lots of steel here. And you can see a lot of shotcrete sprayed there here in these tunnels. This is from Singapore, and the one on the right bottom is from India. Yes, those are man-made material, but these are the support systems which you install after excavating the tunnel, because once you excavate, you remove a material which was there for millions of years. So the stresses readjust, and the physical manifestation of that readjustment is that the tunnel, excavated tunnel, converges. You do not want to permit a lot of convergence, so you install some support. So yes, those are man-made material, but by and large, it is the natural ground which is the key, which is the main material used for tunneling, the soil, the rock, etc. So the key to successful tunneling is to understand this material, the strength properties, the deformability, the stability characteristics of this. That is why investigation becomes so important in tunneling. But the fact is, it is the investigation which is not done properly in most tunnels. In many tunnels, it is difficult to do intensive investigation. In many tunnels, it is neglected. Again, I don't have much time to go into it, but there are issues with this. So you can understand the challenges of tunneling. Now, I have skipped a few slides here in the interest of time, and I've come to this slide. So there have been many questions raised on those slides about tunneling because of the uncertainties. Many of those questions do not have a single answer, but they depend on the individual case, because no new tunnel construction is the same as the previous construction. If you come across somebody who says, I have built many tunnels in similar conditions, don't worry, it'll be a cakewalk. Stay clear of that person. Never underestimate the challenges that you can expect in any tunnel. Okay, so key to understand is that tunneling is not a discrete science. It doesn't have definite answers. There are many unknowns when you're dealing with tunneling, and the answer to most of the question is it depends. So therefore, you need experience, you need engineering judgment to help make a considered and informed decision. And at the end of the day, you carry out the design based on several assumptions, several approximations. So when the tunnel actually goes for construction, a good designer would be biting their nails that you have made assumptions, but now is the test whether the actual tunnel will behave exactly as you perceived it to be. So you have to carry out extensive monitoring, extensive instrumentation once the tunnel starts to be built, because so that you are sure the tunnel is behaving just as you thought it would when you were doing the design. And if not, that the monitoring will tell you that it's behaving differently, and you can accordingly modify the design. Just like investigation, which is so important, unfortunately, instrumentation, monitoring, which is also very important, it is also not given the importance as it deserves in many projects. So more challenges. Now, let's talk about some more challenges in tunneling. Now, when we talk about typical civil engineering structures, we talk about two major aspects, apart from many other aspects, major aspects: design and construction. In tunneling, there are three: design, yes; construction, yes; but tunneling approaches. And these tunneling approaches play a very, very, very significant role in tunneling. What are these approaches? When you come to tunnel design methods, there are several tunnel design methods, and there are challenges. Unfortunately, again, I don't have time to go into it. Tunnel construction methods, different methods for hard ground, such as rock, different methods for soft ground, such as soil. And here are some methods listed for hard ground and for soft ground, and other methods which are sort of not real tunneling, but used for tunneling projects, etc. Again, there's no time to go into it. Tunneling approaches, so design, construction, yes, but tunneling approaches. Many of you must have heard about this term called NATM, New Austrian Tunneling Method, one of the most widely used terms in tunneling, and therefore one of the most misunderstood terms in tunneling. But NATM, and some of you may have heard about Norwegian method of tunneling, NMT, and a smaller number may have heard about 𝗧𝗂𝗧𝗲. Again, I don't have time to go into it. All of them very exciting. And if you go deeper into these three topics, you gain such a lot of wonderful insight into how tunnels behave when you construct them. But this additional aspect which you have in tunneling, which you don't have in other civil engineering structures, lends another challenge to tunneling. And see, when I talk about challenge, I'm not talking about challenge as a negative term. I see anything which, when it has challenges, it is exciting, it is adventurous. Okay, so that's how I look at tunneling. So tunneling is very, very exciting because of the challenges. Now, more challenges. You may have mixed ground condition. Now, some of you are familiar with tunnel. You see tunnel is advanced by excavating the face. That's the tunnel face, and you are excavating it by various means, and you are advancing it, right? You can have mixed ground condition like this tunnel. On top, it's got primarily silty sand, and on the bottom part you have clay silt. So different behaviors, different treatments required. So similar, there are some other examples of mixed ground conditions here. And this mixed ground condition, or these mixed ground conditions, can pose a lot of challenge to tunneling. Again, there's no time because each of these topics, they require half a day at least. More challenges. This is a kind of technical profile. You can see the boreholes there. Going through under a city, usually in the field of tunneling, urban tunneling is considered easier, but I have to use that with caution. Easier in terms of the variability of ground condition as compared to mountain tunneling. But urban tunneling has many more challenges, which are not there in mountain tunneling. As I said, all tunnel projects have challenges, but this is an example of an urban tunneling in the city of Mumbai in India. And you can see even in shallow depth, even in urban conditions where you normally do not expect such variations as you expect in Himalayan conditions, for example, mountainous condition up in north of India. But you can see the variation, and that brings a lot of challenges. Each one of those variations created problems. For example, okay, I have to skip the examples some of the time maybe because we don't have time. Example from Singapore, again, urban tunneling, again, varying ground conditions, which put so much of challenge in the tunneling operation. And some more description of these kinds of challenges in urban tunneling. Talking about the mountain tunneling. Now, you see, you have a short time available and you want to leave an impression. Do it with a lot of drama. Go to the extreme, and that's what I'm going to do. I don't have much time, so I'm going to pick up the story of mountain tunneling with three of the most difficult tunneling media in the world, such as the Himalayas in the Indian subcontinent. You have bit of Pakistan, many Indian states, Nepal and Bhutan, and northeast of India. The Himalayas are considered the toughest tunneling media in the world, followed closely by Andes towards the west side of South America, and that followed closely by the Alps in Europe. These three are younger mountain formations. Geology is not fully settled. So when you tunnel through these conditions, you have widely varying and frequently varying ground conditions, a lot of groundwater, high stresses, fault zones, shear zones, water problems like those, which can make tunneling an extremely challenging operation. Himalayas are the toughest, followed by Andes, and those followed by the Alps. Just to understand a bit more about what sort of problems you can expect while tunneling from these conditions, let's see that the many aspects which influence the behavior of a tunnel when you build a tunnel, like in situ stresses, like induced stresses, geological conditions, rock mass strength, groundwater condition, tunnel geometry, tunnel construction method, etc., etc., etc. Now let's talk about only two of these aspects. Now this chart was prepared by Hock and Marinos. So on x-axis, you have the rock mass quality from left massive down to sheared. Massive means extremely competent, extremely good rock mass, and down to very poor sheared one. On y-axis, you have conditions of stresses from low stress to high stress. Just these two aspects. Combination of these two aspects can result in so many different behaviors when you tunnel through these conditions. So you can see that if you include more parameters, how much more challenging tunneling can become. Now, so when you have different behaviors, you need different design solutions. That's another challenge in tunneling in these conditions. For For example, this little band here is generally favorable tunneling condition. The reason for that is massive means good rock mass. You would imagine good rock mass would be good tunneling condition. Yes, it is, but only when the stresses are low. Because when the stresses start to increase, a good competent rock mass will not be that stable, and I will talk about it in a bit. So this band doesn't go down like this. It goes like this. Why doesn't it go straight, horizontal? Because when you have blocky rock mass, blocky means it's not massive, it has got joints, more joints. And those joints, when they crisscross each other, they form blocks of rocks. These blocks can slide into the tunnel when you cut the tunnel. Now they can slide if they're not properly clamped. For example, here is one block, here's another block. If they are properly clamped, somebody is pressing them together, then they will not slide into the tunnel. But when you have low stress here, low stress, then the stress is not good enough or high enough to clamp them together. They will slide. That is why this favorable band is not going this way. This is going down. When you have some stress, well, that stress is good enough to clamp them together, but not too high. So that's why it goes little inclined, this generally favorable condition. When you have this thing going from left to right, which means going from blocky to poorer and poorer rock mass, in low stress regime, this kind of failure will increase because stress is not high enough. You are in low stress, but the number of joints are increasing when you go from blocky to heavily jointed to crushed, which means more number of smaller blocks, and there isn't enough stress to clamp them together. They're likely to slide into the tunnel. So this is called structurally controlled instabilities. A joint like this is a structural feature of the geology. So controlled by the structural features. When you go in low stress regime, that's what can happen. In the extreme, you can have caving, and I'll show you a picture for that. Anyway, this is what I mean by structurally controlled instability. When you have these joints crisscrossing each other and you cut a tunnel through this, these blocks, for example, these red ones, can fall or slide into the tunnel, provided the joint which is between these blocks has low shear strength. Okay, it can allow it to slide. And you can analyze using a computer program, and you can design these support system, in this case rock bolts, for example. And here is an example. You can see the open joints which will allow these blocks to slide into this opening. Here is an example from a project in Argentina, a 12-meter span tunnel, where from this place, one such block sliding along the joint has fallen freshly on the ground. I experienced one in the state of Kerala in India, and we were standing in the middle of the tunnel. This was 1986. As a young engineer with stars in my eyes, I was standing with a group of senior people. I was looking at them, how knowledgeable these people are. I didn't know much about tunneling. And then somebody says, "Sirs, could you step aside because there's a truck coming?" So we moved to the side, and on the side, there was a puddle of water. So we went ahead 20 meters on the side of the tunnel. As soon as we reached that place, we heard a loud thud, loud sound, and we looked back. Exactly the place we were standing a few seconds back, a big chunk of rock like this, came crashing down. That was the structurally controlled stability or instability. We would have been flattened if destiny hadn't saved us. So I live to tell you the tale. And another time I also saw this, but we knew about it. In this case, which I just narrated, we were not sure. We didn't know about this. Structurally controlled. This is the extreme end of this ภิm'Î chart when you have the caving in, the completely sheared material. You can see it's from a tunnel. I took this picture. Okay, coming back to this chart, if you stay on this massive, good quality rock mass, and one would say, rock is good, tunneling would be a cakewalk. Not really. Massive means hardly any joints, good competent rock mass, and the stress increasing from low stress to high stress. What will happen? As the stress increases in good quality, a good quality rock will behave in a brittle fashion. For example, this is my mobile. If I try to break it, if I apply stress, you won't see any deformation, not much, and suddenly it will break in a violent fashion. But if I hold a piece of rubber in my hand, and if I go on bending it, applying the same stress, you will see a lot of deformation. So you can visibly see that is ductile behavior. But a good competent rock will show a brittle behavior. So what will happen? In the worst case, you will experience rock burst. Rock burst is sudden violent failure. In deep mines, for example, Kolar gold fields in India, which is now closed down, all the gold is taken, 2.5 kilometers depth, I think. Lot of stress because of all this depth, and good competent rock. When it fails violently. It can kill people. It has killed people, rock burst. Now, leading up to the rock burst, you can have severe spalling or spalling. You know, the chunks of or the slabs of rock spalling away. That is a brittle failure in massive rock, good quality rock mass under stress. So spalling and rock bursting happens under high stress in good quality rock mass. Something like this. You see, these are some pictures from rock burst condition. You can see the spalling taking place, and that's how you secure the area. I have a couple of videos to show you, and I'll do that soon. This is a picture from the 𝗏𝗏𝗣𝗏 tunnel I mentioned some time back, very deep tunnel in Switzerland, and it suffered rock burst at some locations around the tunnel, and this is the aftermath of one such rock burst episode. You can see it destroyed so much of material and support system in the tunnel there. Sudden, violent failure. This is also another example. Here is a video. So I'm going to show you very small videos from South America, Andes. In the first video, you will see a minor rock burst. It's kind of a cracking sound you will see, but the area is properly secured, you can see. So it will damage a bit of the support system, but not much damage. But we'll see. After this, I'll show you the real rock burst. I'm going to play the video now. So I hope you enjoyed watching this, and now to the real rock burst. And this video, you see that here is a drill bit. They're trying to do some drilling. I was told that they were trying to de-stress the area. One of the ways of reducing the stress of the area is to drill some holes. I'm not sure whether they are drilling it for what is called the drill and blast operation, or they're drilling for de-stressing the area, but the cameraman is focusing on this part. But something is brewing on the top right part of this tunnel. So keep a watch on the top right, and you will see something coming up. I'm going to play the video, and this is the real rock burst. So you can see the drilling is in progress, but something is going to happen on the top right corner. Let me play the last few seconds once more for you. That is the real rock burst. So I hope you got a glimpse of how does a rock burst look like. And this was the case when you're dealing with a brittle rock mass. So now let's go to the other extreme of this chart, which means now we're dealing with a very, very poor ground condition, shear condition, and a stress increasing. So far, we were talking about increase of stress in massive rock mass, good quality rock mass. Now we go to poor ground condition and look at what will happen when the stress increases. The behavior will be like a ductile behavior, like plastic behavior. In this case, in poor ground condition under high stress, you will not have the violent failure. I gave you the example of the piece of rubber. When I bend it, you see a lot of deformation. So here, what you're going to have is squeezing ground condition. When you build a tunnel in these conditions under high stress, poor ground condition, you will have excessive convergence. Excessive convergence. You know, it can be really frightening. One of the earliest projects which in my career, I remember this was a tunnel in the Himalayas being built. And in those days, we did not have any night shifts. So I remember we used to go there occasionally. And that week I was there with my colleagues, and we were there till that evening on that day. The tunnel was going through a relatively poor ground condition, high overburden, so high stress, 550 meters, I think, under the mountain. And according to the design, very heavy steel supports were put in the tunnel, and the work was closed for the day. Everybody went home. Next morning, I came
Tara,
Yes.
I think there is an issue.
Are you able to hear?
A support system which
No,
is initially flexible,
now it's fine.
which
now
allows
it's fine.
the tunnel periphery to move, and gradually the support system becomes stiffer and stiffer and stiffer. So again, not much time to explain this, but I just wanted to show the contrast. Increasing stress in good quality rock mass and increasing stress in poor ground condition. The behavior will be completely different. Challenges of tunneling. These are some examples of squeezing ground condition. This is from a project in Nepal, and I once visited this project in 2013 in a very remote area. It took hours and hours and hours to reach there. And you see it was squeezing big time. You can see these walls have come inside, and the contractors working in those remote projects didn't have any arrangement to control it. You can see the primitive arrangement they put, the Chinese contractors there. And this is from an Indian project where it's squeezed by more than 2 meters. You can imagine. And the only way you have is to remine the area, which can be very time consuming and which can be very expensive. Now, this picture is the poster boy of the squeezing world. Anybody making a presentation anywhere in the world on squeezing ground condition, they will be showing this. This is from an ADIT. ADIT is a smaller tunnel to approach the main tunnel. There's a project under construction connecting Italy to France, between Turin in Italy to Lyon in France, going through the Alps. Remember I told you about Alps, and it squeezed a lot. It squeezed so much inside. So this the cross section was reduced, and these workers are now preparing to remine this. As I said, remining can be very expensive and time consuming. Apart from these stress related problems, in these difficult mountain conditions, you can have the water coming in, can be hot also, geothermal energy. Now this particular water is coming from a tunnel in the Himalayas, and there was a hole drilled to see what lies ahead of the tunnel face for probing. And water started coming from this, and it started coming. It just kept coming and kept coming for several days. After 1 or 2 days, the fresh water started bringing with it a lot of silt. It was scouring the material, and the silt started coming in. Over a period of time, it inundated the full tunnel up to 1 kilometer, and the tunnel boring machines which was there was covered right at the top. This is close to the face, and this is away close to the portal entrance. You can see the project was delayed by several years. Can you imagine? Just because of this water. So you have these two extremes. In weak ground, you can have squeezing ground condition. In competent ground under high stress, you can have rock burst condition. Sometimes you can have a lot of water coming, maybe without a slush, but this particular project in Andes in South America, heavy flow of water you can see here. This project was delayed by 9 months, and you can stand and watch helplessly. So the trick really is to do good investigation so that you know what kind of problems you are expected to encounter, and you are ready with an answer to that. The first answer is that while you are finalizing the tunnel alignment, do extensive investigation and try to avoid taking the tunnel through problematic zones. Minimize right at that stage. And then if you can't avoid such things, your investigation results will tell you what are the problems which are expected to be encountered, so that you are ready for it, what to do with the plan to tackle this. There are approaches available, and that's the fact. You can take heart from the fact that despite all these problems, there are solutions available. Only thing is you should be aware that you are going to expect any of these problems, so you can build safe tunnels. Okay, so before I close, I'd like to show you one small video, which is from a difficult ground condition, and you will see what sort of condition you can sometimes encounter. all, in this presentation, I hope I was able to give you some flavor of the challenges in tunneling. As I told you that it's simply impossible to talk in any great detail about tunneling and the challenges that you can expect or usually encounter in this small presentation. So thank you very much for your patience, ladies and gentlemen.
Sir, I hope it was audible.
Yes, yes, to me, but it's more important for others to see it. I hope, despite the shortcomings, it was okay. I enjoyed it. I hope. Okay. So,
Yes.
so if there are any questions now, I'll be happy to take the questions.
So I would like, I would like the audience, if you have any questions, then Dr. Manoj is here to answer our queries. Anyone? Anyone?
Sir,
Yes.
am I audible?
Yes.
Yes, Debidatta.
Yes. Good afternoon, sir.
Good afternoon.
Sir, I want to just ask that while this tunneling system is under design conditions, then what are the pre-design decisions are taken? Like if we take a scene of Mumbai, then we are having a very large structures over there. We have pile foundation, since it's all the 7 islands which are combined. So marine zone. So in such kind of field areas, so what is the main governing thing which has a crucial role in tunnel work?
Okay, thank you for that question, Debidatta. It's a very good question. Actually, the question itself has answer hidden in it. At the same time, this question raises many more questions. And in just one question, you have summarized the challenges of tunneling in urban condition, a city like Mumbai. So when you talk about, you have anything more to ask, or should I start answering?
No, sir, nothing much.
Okay. So the thing is that, as he mentioned, the thing is, number one is that one of the requirements early on is that why do you want a tunnel? So you know why you want, why you're even discussing, okay, let's put a tunnel there. There must be a reason for that, which means there's a functional requirement. You want to carry drinking water from one place to another place, for example. You want to carry a certain part of the road, or whatever be the reason, or for a metro project or for a utility tunnel. You have decided to go for a tunnel, right? That's one requirement. Now, right at the beginning, for the planners, and if those planners are not technocrats, which is unfortunately the case in our country and many other countries, then this is the overwhelming requirement. They say, okay, we want a tunnel here, right? So on a map, you will probably draw a straight line, right? So that is the functional requirement. But then the other challenges start to come. The tunnel, this alignment which has been put on the paper might be going through a built-up area with deep foundations. How do you do that? Which means if you must follow that alignment, you have to go down or stay clear of those things smartly. Okay. Another thing you mentioned about marine, which means the geotechnical conditions, the groundwater conditions, the changing ground conditions, all that stuff you have to take into account. So once the tunnel, it is decided, it has to be done, then you carry out what is called a feasibility study. Is it feasible to put a tunnel there, in which all these considerations come into picture? So all those things are taken into account. And when you expand this, once they say, okay, it's feasible. See, one of the main things planners or bureaucrats are looking as a result of the feasibility study is how much will it cost? As they say, it's all about money, honey. So for them, it's money, right? For technocrats like us, money is yes, but money can't buy everything. And tunneling shows you that, right? So after feasibility study, when the go-ahead is given, you do a detailed project report in which you look at these things in more details. You do more investigation to see, okay, and accordingly change your alignment, adjust your alignment, both horizontally and vertically, so that you minimize the problems because of intervention with other structures, as you mentioned, because of the adverse geotechnical conditions, which you mentioned, keeping in mind the functional requirement, etc. And also considering the construction aspects. You can put a tunnel in a very congested area and say that, okay, in this area, we'll build the tunnel from the surface. It's not real tunneling, but cut and cover. But in Mumbai, you hit rock 5-6 meters, as you mentioned, to create those boundary walls for cut and cover. For example, you need to mobilize hydro-phrase bigger equipment, but the houses, the balconies are protruding so much, you don't get the headroom. So I'm just giving you one of the hundreds of examples. So you say, okay, this method is not possible here because we can't mobilize the equipment here to do this. Stuff like that. So as you go deeper into this, this goes on expanding. So all of those things are taken into consideration.
Yes, sir. Thank you, sir. So one more question, sir.
Mm-hmm.
Sir, just a personal one. Like in your whole career, which part in this tunnel work was the most difficult for you? Just a personal one.
It's a risky question.
Please don't mind.
No,
Yes.
no, not at all. It's a risky question because it's like if I say that, okay, in this class of 43, 44 people today, Devidutta has better questions than others. Others may not like it. So similarly, the tunneling, everything can be challenging. Everything can be challenging. Some of the least expected things can throw surprises. You have to pay equal. I give you an example. A few years back, Chennai Metro was under construction, and the section of the tunnels between Pachiyappa College and some other, that both the tunnels were constructed up and down line, and then they were to construct the cross passages for evacuation during things. Now cross passages only a few meters long, and they started constructing the first cross passage, and they had excavated only 1 meter, and water started to come from the bottom. It simply kept coming. After a while, it started scouring the sand there. Now the sand there was going inclined below the tunnel. So the foundation being offered by the sand there was being removed. So tunnel started to tilt, and all the segmental lining and everything has started to go haywire. It set the contractor back by 10 crore rupees, just 1 meter of excavation into a cross section. And they say, cross section, 2 meters, 2.5 meters, we'll finish in 2 days, 3 days. That can happen. Now there's a whole story because I was there for 15 days, and literally we were, as if we were holding the tunnel like this. We were not actually, but we were feeling, it could fall anytime, but it was saved for somehow. So anything can be challenging in tunnel because it's underground. It's hidden from your eye. Okay. And imagine a building on the top and a tunnel inside. I tried to bring it up in the presentation, but the time was less. But the more you think about tunnels as compared to the above ground structure, the more you know why tunneling is so profoundly different from other structures, and why universities start to teach tunneling in more detail.
Yes, sir. Thank you. Thank you so much.
You're welcome.
Sir, I think on behalf of everyone, I would like to share that Dr. Manoj Verman is also linked with one of the national strategic importance project, which is, is brought up into the Uttarakhand, a railway project, which is linking Rishikesh to Karnaprayag, which is having number of tunnels. And I guess, sir, if I'm not wrong, total tunnel length is, if we add up the number of tunnels, the length comes out to be either 125 kilometers. And we do have...
The thing is, sorry, the total alignment is 125 kilometers.
Okay, sir. And one of the longest tunnel is around 15 kilometers, which is longest in the country. Sir, would you just throw some light into that project and how you worked out, please?
Yes. Yeah, this was way back in 2012, I think, when this started. Okay. So Rishikesh to Karnaprayag. The idea is to link Rishikesh with Badrinath. Badrinath is a holy place for Hindus, but that was not the real reason. People don't tell you. It is for defense because Badrinath is also at the China border, for fast movement, etc. For public consumption, yes, it's for Tirth. Okay, yes, that's a purpose also, but then the main was this. That's how Ministry of Defense was involved in this.
Oh.
So Rishikesh to Badrinath. But then this can't be done in one phase, money availability, another thing. So it was divided in two phases. The first phase, Rishikesh to Karnaprayag, and then later on, I don't know when, Karnaprayag to Badrinath. Now the work was given to this Italian company, and I was working for the Italian company, and I was fortunate to be the lead on that project. So we had most of the people from Italy, so some very, very competent people, and some Indians, and I was leading the combined team. And the beauty of that project was, and that's why I loved the project. We were given a clean slate, a clean canvas. Look, gentlemen, this is the canvas. These are the colors. Fill whatever colors you want to do it. And you see a person like me who doesn't want to be, you see, that's why I left my job actually 7 years back, because I didn't want to be, in the cage anymore. In the corporate world is tough actually. Okay. So I said, wow, this is fantastic. So whatever I've told you, we followed the practice. Right from the time of deciding how the alignment will go, we took into account the likely difficulties while keeping the functional requirement in mind. For example, we were given that, okay, Rishikesh to Karnaprayag, but on the way, these 10, 11 places must have stations. So you can take the train anywhere, but they must come back to this, to Kordiala, to Srinagar, to Rudraprayag. So the thing is, we try to minimize the problems, avoiding the fault zones to the extent possible, or minimizing the traverse, etc., etc., etc. It was so difficult to find space for stations, and there are so many stories actually which will never be documented, and they're still with us. So I actually told people who were involved at that time that let's bring out a coffee table book, So those things are not documented anywhere.
Sir, you're welcome at SEP then. Physically, we will have a round tea.
Actually, if
with our students,
if SEP can take the lead, I can talk to those people and create.
Definitely,
this.
Sir.
Just to give you a quick example, because you've got me going now. So is that, you see, there's a place called Srinagar in Uttarakhand. There's Srinagar in J&K also, Srinagar in Uttarakhand. So the thing is, it's the most important place along that alignment, because the most floating population is in Srinagar, because they have the NIT there, they have the medical college there, they have the university there. So students and lots of movement. So they will be using the train the most. Now, from Rishikesh, when you go up, it's along the river Ganga, and it is, when you're going up, it is on the right. Usually the river is flowing down, so we say to the left of river. But when you go from Rishikesh up, it's on the right. You go on right, okay, one station, second station, you're taking the alignment, right? And then comes Srinagar. So we wanted to put the station to the right. Now on the right, it's all hill in Srinagar. Then you have road, valley, river, and the hill. So a station was to be put an underground station under the hill. Now, Railway Board said this is not a commercial project. We won't be ticketing a lot, will not be any. So creating an underground station and maintaining it 24 hours, light and air conditioning, everything can be a problem. Let's put the station on the other side of the river where there's space available. What does it mean? It means we have to cross the river, and putting a big bridge is a big project in Himalayas. So we crossed it, went to the other side, and you see the train cannot turn like this, like a car. It has got its own radius of curvature. So we went and found a place, put the station there. Now, immediately after the station, there's an existing hydropower station, which means we can't take it on the other side. We have to again cross the river and come back to this. So 2 additional bridges. Now, many people 20 years from now, they'll say, they were fools, the people who built the alignment. See, they wasted taxpayers' money. Why did they put 2 bridges? That's the story, is not documented anywhere. So stuff like that, you see. And you see, recently I was there, and I was looking from the top of the hill. On top of when you go to Srinagar, there's an IV place, some restaurant. From there, you see whatever we could see on the map. You are able to see those things taking shape. The tunnel is coming up, the bridge is being built, the other bridge is being built, the station is under construction. So it's so lovely to see your baby taking shape, actually. So there are many such stories. Maybe someday I'll travel to Ahmedabad and maybe.
Sure, sir, you need to. And sir, some insight into your Maharashtra tunnel project right now.
Okay, this project where I'm at the moment, I'm in my hotel room, and actually the office here has the Wi-Fi, but I'm not allowed to go there because it's been hit by COVID-19. So being an old man, they say, okay, you stay away. Okay, so that's the thing. So I'm enjoying my stay in my hotel, working from hotel, working from hotel. So that's why I'm on this hotel. Is a small place. There's nothing in this. So this project is a highway tunnel on the road which connects Pune to Bangalore, or if anybody of you from Maharashtra, is Pune to Satara. And when you travel from Pune to Satara, just before Satara, about 30 kilometers before Satara, 35, you have this project. So currently, what is the scene is that when you come from Pune to Satara, there's no tunnel. So there ghat road, you have to go round and round and round and round, takes a lot of time. Okay. When you return from Satara to Pune, there's a tunnel. There's an existing tunnel. But then as soon as you cross the tunnel, unfortunately, somebody 20 years back built alignment. As soon as you come out tunnel, there's a face of rock mountain. And there have been many people who were driving fast through the tunnel and they hit that rock and they die. So there's an S curve kind of thing, which is very sharp, which shouldn't have been done. So this new project is at the side of that, where it's a 6-lane project. There are 2 tunnels under construction. Pune to Satara will also put in a tunnel with 3 lanes. And the Satara to Pune, to avoid that problem, will also be put in a tunnel. So 3 lanes coming, 3 lanes going. Okay. And so it's not a very long tunnel. But the challenges of tunneling in these conditions here are very different for Himalayas, for example. I told you that there could be stress-induced problems like rock burst and squeezing. They're stress-related. Those are the things that you expect in Himalayas. High stresses and soft ground condition. Here, hard ground. These are old geologies, basalt, and not very high stresses. But here you will experience that sliding of blocks, the structurally controlled instability. That's to be seen. But the problems are much less here. So this is the problem. If you want to see some of the pictures, sites, etc., and Dr. Dharasha introduced me as an actor also, it was a bit of embarrassment for me, but also I was happy from inside. So I have a YouTube video, which I prepared when I came here first more than a year back. I was so taken by the beauty of this area. And then people told me that this is an area called Y, is very, very popular with the Bollywood. Okay. And more than 350 movies, Hindi movies have been shot here. And right now you see many TV serials being shot, units staying here and there, and you get up and the song being shot, etc., etc. So I did a small video on this. In that video, I also showed the project status at that time. This is November 2020. So I'll send the link to Dr. Dharasha.
Definitely, sir.
Yeah.
Okay, thank you very much, sir, for your beautiful insight and journey into the tunnels. Live seeing this bursting and squeezing of the tunnels, we just wonder how the nature can make this happen, squeezing of a tunnel, coming together with both the sides. And it was a very wonderful experience with you. Once again, on behalf of everyone, I'm very, very thankful to you. You accepted this invitation and you came here as an eminent speaker. So thank you very much, sir. And we look forward for that Rishikesh to Karnaprayag project.
Sure.
Talk with tea, round table,
okay, yes.
etc.
Yes.
Along with your colleagues. Yes, sir. Thank you. Thank you very much.
Thank you very much.
Thank you. Yeah.
Bye.